What does it do? It makes us pee. Well, it extracts waste from the blood to bound bodily fluids, forming urine. How does it do this? First, blood enters the kidney through the renal artery to begin ultrafiltration. This is a process in which metabolic wastes are separated from the blood, forming urine. Blood is filtered in the Bowman's capsule. The kidney is made up of over 1 million nephrons, pictured here. The Bowman's capsule is the first part of the nephron, and as said before, where blood is first filtered. In the Bowman's capsule, there are capillaries that form a tuft called the glomerulus. Walls of the capillaries have pores called fenestration. High pressure forces water and blood across the capillary wall and basement membrane, thus filtering impurities out of the blood. So what's the next step? The next step is called reabsorption and occurs in the proximal convoluted tubule, or PCT for short. The PCT is the section of the nephron immediately after the Bowman's capsule and extends to the loop of Henle. So what's absorbed? Hormones, mineral ions, and vitamins are actively transported across the membrane. Water performs osmosis and follows the movement of ions passing. High concentrations of substances in the PCT allows them to passively diffuse into the bloodstream. There are lots of microvilli located here for a larger surface area to absorb more of these substances. There is also lots of mitochondria in order to make ATP for the substances to be actively transported.
Now we are on the last step, which is called osmoregulation. Osmoregulation occurs in the loop of Henle in the medulla of the kidney. And here's the loop of Henle. The loop of Henle establishes a salt gradient that is hypertonic, and it's a hypertonic environment in the medulla. An antidiuretic hormone, abbreviated as AD, regulates the water level reabsorption in the loop of Henle. The loop of Henle generates a high concentration of solutes in the fluid of the medulla. In the descending loop of Henle, it's permeable to water but not salt, so water is lost here. Water is lost. In the ascending loop of Henle, permeable to salts but not water, so that means salt is lost. The salt is lost. As the loop goes down into the medulla, the fluid becomes hypertonic and salty. The blood network that surrounds the loop of Henle flows opposite the filtrate. So the loop of Henle goes in this direction, while the blood network flows in the opposite direction. And this blood network draws out sodium chloride, also known as salt, and H2O. The last part of the nephron is the collecting duct, and as it passes through the hypertonic medulla, water will be drawn out. And the ADH, the antidiuretic hormone, controls how much water will be released by the collecting ducts to be retained by the body. If the water content of the blood is too low, the ADH increases the permeability of the collecting duct, and less water remained in the filtrate urine becomes concentrated, and there's less urine. But if someone is properly hydrated, the ADH will decrease and the urine concentration will lower. Finally, the urine goes to the bladder. You know what happens next. Thanks for watching.